Hi everyone, we're back as part of Live at BTI Giving Tuesday here. My name is Felix Fernandez-Penny and I'm joined here with Annett, Richter, and Cairo Archer from the Jander Lab. So today we're going to talk a little bit about mentorship and some of the mentorship programs here at BTI. I've had a wonderful past with the mentorship program here as a former high school intern and PGRP intern. And so we're going to touch a little bit on those programs as well as kind of the culture of mentorship and cultivating a collaborative scientific community here at BTI. So without further ado, I'd love to just have you guys do a brief introduction and talk a little bit about your history with the Institute and then take it away.
So I can start.
Yep.
My name's Cairo Archer. I'm a senior at Cornell now, and I started at BTI in the summer of 2014, fresh out of high school, doing the PGRP high school internship. And from there, I was pretty hooked on research. I had a great mentor, and I stayed on at BTI up until today. So I've been here for a while.
Yeah, so my name is Annett, and the first time I went to BTI was 2 years ago for a collaboration project. So I did my PhD in Germany, and for the collaboration project I was working on maize and defense against herbivores, especially caterpillars. And so yeah, the project was really cool, and the last day I remember George asked me if I want to stay in his lab as a postdoc, and I was really happy to say yes.
That's great. That's great.
Yeah.
It sounds like you guys have a really kind of have had a welcoming experience here at BTI. So turning to the mentorship idea, Cairo, you mentioned kind of the PGRP program, and the high school internship program. Would you mind kind of touching on those experiences and how they kind of led to where you are now, your course of study, and the like?
Yeah. So the high school program kind of fell into my lap. I had a great friend, Felix, who was in the lab with me, and he told me about it. And my biology teacher at the time encouraged me to apply, and I'm very happy I did because it kind of shaped my trajectory at Cornell. The program is the reason I'm now a nutritional science and plant science double major, and it's also the reason I want to continue doing research for the rest of my career. So it shaped me career-wise, and it also just shaped me general skill-wise. Asking scientific questions is a very important thing to learn, especially in our world today. And I've learned how to think critically, how to assess things in a more logical fashion, and how to conduct experiments and potentially work in a lab full-time.
That's great. I can only echo those sentiments coming from a similar perspective as well, but have gone in a slightly different direction. But so, Annett, we just talked about mentorship here at BTI, but I'm wondering if kind of in your professional history and whatnot, ways that you've encountered mentorship in the workplace and in kind of leading you to where you are as well.
Yeah, I'm kind of jealous because I never had the experience to have a mentor. So we have a similar system now in Germany, but that started when I was nearly at the end of my PhD thesis. But when I was a diploma student, which is like similar to an undergrad, I had two supervisors, Andreas and Ingo, and they really helped me to learn all the methods in the lab and then how to think as a researcher. And by that way, or in that way, I really started to like my job. And then, I'm a really happy person that I can do what I'm doing now, and so that was great.
Do you think for both of you, do you think the directions that the projects you work on and the directions that your various kind of mentors and mentor figures pushed you along the way, do you think that's really curated your research project and kind of where you focus your kind of the academic side of things now?
Yeah,
in terms of subject topic.
Yeah, I started working with Kevin when I came here when I was doing a lot of genotyping stuff, which was cool. But then when I got to work with Verit, I learned a lot more about caterpillar herbivory. And then when Annett came here and we met each other in the cornfield, we
met in the maze,
in the
you could
maze,
say.
Right?
Yeah, exactly. I learned more about what she did during her PhD thesis, and I was really interested in it. So that's kind of how we ended up working together.
Yes, because she's now doing something similar what I was working on during my PhD thesis. So as I mentioned before, so maize is producing some volatiles after her caterpillars are feeding on them. And these are like a blend of odor, which are like similar to call for help because they attract natural enemies of the caterpillars, for example, wasps. And when they are attracted, they oviposit their eggs into the caterpillars. And then the larvae are feeding the caterpillars from the inside out. I know it's gross, but at the end, maize has less feeding damage and can survive. And so she's working on something similar because we are having a mutant line which is lacking in producing some few volatiles. And where it was showing is that aphids are growing less good on those mutants.
Wow.
So it might be that the volatiles are probably attracting the aphids to feed on them.
Yeah.
Right.
And when they're gone, they don't have a source of attraction anymore.
Yeah.
Yes.
Wow. Wow, that's so wonderful to hear that the kind of the BTI community brought you guys together and that's really sparked this research project, which sounds like it has some serious kind of global implications on food supply and the like. So I guess turning to that side of things, I'd love to hear a little bit about kind of the project you're working on, and if you could just walk us through that would be, enlightening for a lot of our online viewers.
Yeah, sure.
Yeah, I'm really proud to say that Cairo is very independent in our lab, and she introduced the EPG, it's the electrical penetration system, in our lab, and it's a cool thing because maybe you want to explain what you can measure with that?
Yeah, so the EPG is one of the coolest machines I've ever gotten to work with. Don't want to plug it too hard, but it's really great. Essentially what it does is it allows you to track aphid feeding pattern over time. And it does that by inputting electrical currents into the aphid, very minute ones, so the aphid doesn't even know what's happening. And you can track where the aphid is feeding in the plant, at what level. And we actually have a little diagram I can show you of this system. So you have a cage, a Faraday cage, that surrounds the aphid, the plant, and a grounding cable. And this cable connects to the soil just to establish a baseline current. And then the cable connected to this machine right here is connected to a metal probe, which is then connected to an aphid in a very complicated mechanism that I will show you in a second as well. And when the aphid feeds, a full circuit is completed. And this diagram doesn't show a computer, but off to the side, there's a computer that tracks all of the different electrical impulses that are triggered by this aphid feeding.
Wow. And you only get a reading when the aphid completes the circuit by feeding.
Exactly.
That's fascinating.
Isn't
So
it
you
cool?
get some wavelengths,
That's so cool.
and with those wavelengths you can see actually what the aphid is doing, if
Feeding
it's drinking, or just penetrating, or sleeping, whatever.
Oh wow,
Okay,
so you can
sleeping.
really
Not
identify.
sleeping. Sometimes it seems like they're sleeping, but they're not.
But
Like the first 2 hours they're usually doing nothing, they're just
There's
they're
rolling
shocked
around.
what's going on, and then they start feeding, then they're just drinking, right?
Yeah.
So that's what we experience.
Exactly.
But you can gauge kind of the level to which they're feeding, or that's incredible.
And
Yeah,
which
well-
cell layer they're at.
Which
is really
cell
cool.
layer? Wow, incredible detail.
Yeah, and that's why we're using different plants, the mutants versus wild type, to see if there's a difference in the feeding behavior. So, of course, there should be, because when they're growing less on the mutant lines, so we think there should be also a difference in the behavior. So the question is how we connect the aphid to the wire.
Okay.
That's the cool thing.
Sounds like a bit of a process.
If you don't have good eyes,
Oh,
I
yeah.
recommend doing this.
So this is
Here's another
a
image.
picture taken under the microscope. So, so this aphid is not as big as shown here. It's really
Very
tiny.
small. And this is actually a gold wire right here. And we have a spool of gold wire on the floor over here, but it's the size of a hair. So it's very tiny.
Just so y'all can see.
It's really tiny.
You won't even be able to see that in the
Minute.
Yeah.
Wow.
Yeah. And what we do is we take a very small section, about a centimeter, of this gold wire and attach it to the abdomen of the aphid using silver glue, which we also have a little bit right there. If you want to grab a few.
You can see.
It's very pretty looking. And all of this is done under a microscope.
Wow.
I can do it with a naked eye, but I don't recommend
I
it.
couldn't do it in the
took me a
beginning.
Do you choose to do it with the naked eye, or do you much like? Is that just a?
Yeah, actually, I do, just because my motor control is easier when I'm just looking
Not looking
at
through a
it.
pair of binoculars.
Yeah, exactly.
But the question is, how can we keep the aphid in this position? So because it takes some seconds until the glue is dry and the wire is reconnected, because if they're moving, the wire always gets loose, and that's really tricky.
Exactly.
But George found something, or he established a system. It looks really weird, right?
Oh.
So no one knows what that is.
I don't know, that intimidates me a little bit.
So what we do is we set up a vacuum.
Okay.
And then with the brush, we put the aphid on the top of this tip here.
So a paintbrush or something?
A paintbrush,
Small
yeah.
paintbrush? Okay.
And then the aphid cannot move anymore. It's just stuck there.
Yep.
And you have to be careful how you put the aphid on it so that it's not the back or the head. Sometimes it's the head in there, right?
Yeah, and
Oh, no.
unfortunately,
Yeah.
it's stuck there.
Little aphid
So-
casualties.
Yes.
Oh no.
Yeah, but we try to keep them happy, so usually that's really good.
Exactly.
It works good, yeah.
Yeah, and then once you attach it correctly, you can put it on an actual corn plant and let the system run. Usually we run it for 6 to 8 hours, trying to get it to 12, but we're having some issues with the computer. So.
Wow. So how many aphids can you track at a given time? Can you bring multiple feeds back into the computer, or
Yeah.
I mean, it would seem time consuming if you were doing one aphid at a time. So
We can track 8
8
at
okay.
once if
Wow.
all the probes are working, and right now all of them are working.
Yeah, they're all
That's
working, 8 lines and 8 at the same time.
And this is a system that you introduced to the lab, or is it something that you developed in-house, or?
So this is a machine that George decided to purchase.
Okay.
Actually, it's for the whole institute technically, if other people wanted to use it. But right now, I think we're the only ones who know how to analyze the data, but it doesn't take too long. I learned how to do it over a summer.
Although the analyzation at the end, that takes some time and
Yeah.
experience, because there are a lot of different wavelengths and you really need experience to see what's going on, what's happening, and it's a lot of reading of publications where other people have done similar things.
Exactly. I can actually show you guys an output.
Sure.
We have lots of things prepared for you.
Oh.
So this is what a reading would look like over time. This, I believe, is only 30 seconds, but this is a course of an hour.
Okay.
And each of these little peaks can be categorized into how the aphid is feeding. So this peak is actually representing drinking. Actually, no, this is phloem feeding. So the aphid's actively consuming phloem at this point. These things are kind of noise, like the aphid's not really sure what it's doing. It's probing, but it's not
making a
actually
decision.
eating. Yeah.
Yeah.
And then this is all just constant eating.
That's constant feeding. Okay.
So this
that's
is what
1
we like
hour,
to
right?
see. Yeah.
Yeah, so you see
Yeah.
it's a long time of feeding.
Great. And this is a result of those volatiles that you were mentioning, where the aphids where the aphid feeds naturally, right? But then you're going to be tracking this volatile production after the fact.
I mean, the volatile production, I don't think that we don't measure the volatile production, so we studied that already.
Okay.
And usually the volatiles are not that highly induced by aphids, it's more or less by caterpillar induction.
Okay.
But
So
still
this is
it's
just a
producing
separate
a
brain.
minor level of volatiles, and so we think that this has an effect on the aphid feeding, or even reproduction, right?
Right. And I think the main thing that this is trying to get at is preference. If you see longer durations of this phloem feeding or just active eating stage, you can then infer that the aphid prefers one line of maize versus another.
Right.
But concerning your question, we have another experiment, a choice assay, right? So we have all the volatiles produced by this one gene. These are in total four. We have, and you want to do some choice assays, right?
Yeah,
to see
exactly.
Maybe you can.
Yeah, so we just kind of want to see if the aphid likes these volatiles or not, and we're working with them in concentrations that would be mimicked in the plant, so it's not like we're bombarding an aphid with volatiles. And we want to see if they like it, if they don't, and then that could help indicate why we see the feeding patterns that we do with the EPG.
Cool.
I
We
have
have
someone.
our surprise guest here.
Yes. So this is Lucy. She is an intern, or she
Feel
has
free to
been.
pull up a chair.
Yeah.
Like to join.
Hi, Lucy.
Hi. Good to see you.
Here, we can all scoot in a little bit. I just want to make sure we stay in frame.
Yeah, Lucy has been an high school intern last summer.
Great.
And she did a great job, and that's why I asked her to come back
That's
to
amazing.
work in the lab. And I'm happy that she's here, and maybe you can just introduce in 2 sentences yourself.
Sure. Tell us a bit about yourself. What brought you to BTI?
Well, my name is Lucy. I'm a senior in high school at Ithaca High School right now.
3 Ithaca High School.
I know,
right here.
continuing the lineage.
The legacy in the Jander Labs.
Well, I applied for the summer internship at BTI last summer. I thought it'd be a really good opportunity to learn more about what science really was and how research can be more applicable to my life. And I thought it was a great experience, and I'm glad to be back.
That's great. I'm so glad to hear it. Has it helped you kind of, I mean, obviously this is a very, filled, busy time for you in senior year and whatnot. Has it given you any kind of indication where you might want to head next, or kind of what your upcoming plans are?
Yeah, well, I think I'm actually interested in maybe pursuing like nutritional science.
Oh, wow.
And major in nutritional science, so yeah, it definitely opened my eyes to that.
We should talk after this.
Yeah, absolutely.
We have to talk anyway after this.
Yeah. We won't touch on that, but no. So it sounds like this project has a bunch of different facets to it. So I wonder kind of where you see the next steps going, kind of what, if there is an end goal, or whether this is something that you really just see kind of continuing to evolve. I know how science can be kind of ever changing and whatnot. Just future directions and whatnot for where you might be taking this research.
Yeah, I think
And feel free to chime in as well.
No.
No, I think at the end we're definitely working for publications, which would be good for every one of us. And so I really hope that after that, when you are done, or a student, that we can still have collaborations. That's always nice. And
Yeah, and I think I'm also working on an honors thesis, so this is something that'll be included in that for me.
Great.
And you'll get to learn how to use the EPG, which is kind of cool.
yeah, because she wants to help us now to analyze all the data sets.
Wow.
And so when we are fast, we can publish soon.
That's great. Yeah.
Yeah.
So outside the kind of immediate fundamental science community, what are some of the broader implications that this research touches on, in terms of the public, food supply, that sort of kind of realm of the broader implications of the project?
I guess I can talk a bit about that. As we all know, maize is one of the most important crops in the United States, hands down. And I think what this research is trying to do is to see if we can isolate lines that have either reduced resistance or increased resistance to these pests that affect the livelihoods of so many people in our community, in our immediate community, but also globally. And this project especially is interesting to me because our line that we have is actually more resistant to aphid. Not more resistant. Aphids don't like it as much.
Okay.
Which is kind of different because normally when we find knockout lines, the aphids like it more.
They love it.
So
That's
this
not
is
exactly what
exactly, and so that's why we were so drawn to TPS2 to begin with, and I mean
That's the knockout.
that's the knockout line, yeah, and I guess if we were able to continue the work that we're doing now, we could try and see if this line could be applied in a field setting, if it grows well, and
that
carry
offers
that
potential
on.
for better yields and a whole plethora of assorted maize pipeline.
Yeah.
Wow, that's
It's
great.
so amazing.
So I'll begin to kind of wrap up, but you mentioned kind of collaborations and that network within the scientific community, within the BTI community. Are there any collaborators that you're working with that you're particularly excited about, or just kind of interesting partnerships that this research involves?
Yeah, I mean, I still have collaborations in Germany, and there is Tobias Kölner. He's a great scientist, and so he's working at Max Planck Institute, Jena. And I still have collaborations with my former lab, of course, in Halle, and there are also some labs here in America, Eric Schmalz, for example, or in Switzerland. So there are a lot of collaborations.
Really?
Or even in Japan. So I went to so it's really cool.
That's great. Well, this has been really, really eye-opening and fascinating research, and also wonderful to hear a little bit more about the collaborative community here at BTI and the mentorship opportunities available to students and aspiring scientists and professionals as well. So I want to thank you all for being here and for sharing with us a little bit about your experience. And I look forward to kind of seeing the publication that's in the works. All right, thanks.